Intricate Devo. Intricate.
Hello everyone, and welcome back to Intricate Devo, where complex programming concepts become simple, practical, and fun to learn. Today, we're exploring one of the most powerful concepts in object-oriented programming, polymorphism. But before we begin, I have a quick challenge for you. If you're serious about becoming a Java developer, take a second to support the channel. Hit the like button, comment Java Mastery below. Share this video with a friend who is learning Java. And subscribe to Intricate Devo so you never miss our complete Java learning journey. Alright, let's get started. Imagine you have a TV remote. You press the power button. If it's connected to a Samsung TV, the Samsung TV turns on. If it's connected to an LG TV, the LG TV turns on. If it's connected to a Sony TV, the Sony TV turns on. The button you pressed is exactly the same, but the result changes depending on the device receiving the command. That's exactly how polymorphism works in Java. One action, many different behaviors. And that's what makes it such a powerful concept. So what does the word polymorphism actually mean? The word comes from two Greek words. Poly means many. Morph means forms. Together, polymorphism means many forms. In Java, polymorphism allows objects that are related through inheritance to respond differently to the same method call. One method, different outcomes. That's the essence of polymorphism. Let's understand this with a simple example. Imagine you're standing in a zoo. You shout, make a sound immediately, different animals respond. A dog says, bow wow, a cat says, meow. A pig says, wee wee. A bird says, tweet tweet. You gave only one command, but every animal responded in its own unique way. Congratulations! You just experienced polymorphism in real life. Now let's bring this idea into Java. On the screen we have a parent class called animal. This animal class contains a method called animalSound. Next we create child classes called pig and dog. Both classes inherit from animal, but each class provides its own version of the animalSound method. The pig class says, the pig says wee wee. Dog class says, the dog says, bow wow. Notice something important here. All classes use the same method name, animalSound. However, each class performs the method differently. This is known as method overriding. Now here's where the real magic happens. Suppose we create three objects. An animal object, a pig object, and a dog object. But instead of storing pig and dog inside pig and dog variables, we store them inside animal references. At first glance, that might seem strange. Why would we store a dog inside an animal variable? Don't worry. This is exactly what makes polymorphism possible. Now imagine calling the animalSound method on all three objects. The animal object produces a generic animal sound. The pig object says, wee wee. The dog object says, bow wow, but wait a minute. The pig object was stored inside an animal reference. So why didn't Java execute the animal version of the method? This is where Java becomes incredibly smart. At runtime, the Java virtual machine looks at the actual object in memory. Even though the reference type is animal, the JVM sees that the real object is a pig, because or that it executes the pig version of animalSound. Similarly, when it sees a dog object, it executes the dog version. This behavior is called runtime polymorphism. You may also hear it called dynamic method dispatch. The name sounds complicated, but the idea is simple. The actual object decides which method runs, not the reference variable. If this explanation is making polymorphism easier than your textbook ever did, hit that like button right now. And comment bow wow below if you're still watching. Let's continue. Many beginners don't realize that Java supports two types of polymorphism. The first type is compile-time polymorphism. This is achieved through method overloading. When multiple methods share the same name but have different parameters, the compiler decides which method to execute before the program runs. The second type is runtime polymorphism. This is achieved through method overriding. In this case, the JVM waits until runtime to decide which method should execute. This is exactly what happened in our animal example. Now let's talk about a concept that appears in almost every Java interview. Upcasting. Imagine creating a dog object and storing it inside an animal reference. This is called upcasting. The process is automatic. It's completely safe. And it forms the foundation of polymorphism. However, there is one limitation. Suppose the dog class has a special method called fetch. Since the reference type is animal, the compiler only knows about animal methods. It doesn't know anything about fetch. So calling fetch directly won't work. To access dog-specific methods, we need something called downcasting. Downcasting converts the parent reference back into a dog reference. After downcasting, dog-specific methods become available again. But there's a catch. Downcasting can be dangerous. Imagine storing a pig object inside an animal reference and then trying to convert it into a dog. Java immediately throws a ClassCastException because a pig is not a dog. And that's where many beginners run into trouble. So how do professional developers avoid these crashes? They use the instanceof operator. Before performing a downcast, they check the object's real type. If the object is actually a dog, then the conversion is safe. Otherwise, the program avoids the cast entirely. This simple check can prevent many runtime errors. Modern Java made this even better. Starting with Java 16, pattern matching for instanceof allows us to perform the type check and create the cast variable in a single step. Less code, cleaner code, and happier developers. Now let's look at a real-world example. Imagine you're building a video game. Every character has an attack method, but different characters attack differently. A warrior attacks with a sword. An archer attacks with arrows. A wizard attacks with magic. The game doesn't need to know which character it receives. It simply calls attack. Each object decides how the attack should be performed. That's polymorphism in action. And that's why polymorphism is used everywhere in professional software development. Let's do a quick recap. Polymorphism means many forms. One action can produce different results. Method overriding enables runtime polymorphism. The JVM chooses the correct method at runtime. Upcasting is automatic and safe. Downcasting is manual and should be used carefully. The instanceof operator helps prevent runtime errors. And polymorphism makes software flexible, reusable, and scalable. Before we finish, here's today's challenge. Answer this question in the comments. What happens when we call animal sound on a dog object that is stored inside an animal reference? I'll be reading and replying to as many answers as possible. And there you have it. Java polymorphism explained simply. If inheritance gives objects shared abilities, polymorphism gives them unique personalities. Together, they form one of the most powerful foundations of object-oriented programming. If this lesson helped you understand polymorphism, please support the channel. Like this video. Comment polymorphism mastered below. Share this video with your friends, classmates, and fellow developers. And subscribe to Intricate Devo for more beginner-friendly Java tutorials. Thank you so much for watching. Keep learning, keep building, and keep coding like a pro. I'll see you in the next video.